Everybody. This video is going to be about the first and the second topic of chapter 1, sorry. Well, let's take a look at the first topic, atoms and molecules. Long time ago, 500 BC, these two philosophers developed some ideas about the possible units of the materials around us. Okay, so they said that the units are called atoms. Okay, and these atoms are small and hard particles, and they are made of the single materials. Okay, with to form different shapes and sizes, and then they're always moving around. Those tiny units. Okay, of course, at that time they don't have the fancy equipment or facilities or instruments to verify their ideas. But nowadays we know, indeed, the materials around us, the basic units for them are atoms. Okay, and atoms connect to each other through chemical bonds to form molecules. Okay, and those molecules will interact with each other through intermolecular interactions to bind together to form either gas, solid, or liquid. By the way, you will learn intermolecular forces in Chem 2. Okay, so in this college chemistry 1, we are going to focus on the chemical bonds, covalent bonds, ionic bonds, or metal-metal bonds. Okay, three basic types of chemical bonds. But anyway, when those atoms connect to each other through chemical bonds, they are going to form different molecules. Okay, and these different molecules will have different chemical and physical properties. This slide shows you two examples, carbon dioxide and carbon monoxide. Carbon dioxide, we know it's a very famous greenhouse gas. Okay, it's released by the power plant, for instance, okay, to the atmosphere, and because of carbon dioxide can absorb the heat from sunshine. So if you have too much of carbon dioxide in the atmosphere, it could potentially impact the climate of the whole world. Of course, this is still under debate, but certainly one thing is for sure: we don't need too much of the carbon dioxide in the atmosphere. Okay. Anyway, so why do I want to compare these two molecules? It's because both molecules have the same types of atoms. They have two types of atoms: carbon. Okay, yeah, in these two diagrams, carbon here on the carbon dioxide, the black ones carbon, and oxygens, the red atoms. Okay, in carbon dioxide, you can see that carbon is the central atom and two oxygens on the two sides. So it's sort of like a linear molecule, a straight line. For carbon monoxide, it has one carbon and only one oxygen. Still a linear molecule, okay? But when you compare those two molecules, you can see the difference, okay? Carbon dioxide has one more oxygen. And this tiny difference caused the totally different chemical property of those two molecules. For instance, carbon dioxide has no smell, and they are very inert, they are very stable, and they are not poisonous. But for carbon monoxide, it's highly poisonous. It can kill you, okay, if you are not careful enough. And actually, every year there are a couple of cases about the carbon monoxide poisoning cases in the U.S. Okay, but anyway, you can see that different molecules will have different chemical property, even if they have the same types of elements or atoms. Okay, so our focus in chemistry would just to explain why those molecules would have different properties. All right. So as you can sense now, for chemistry, it's like playing Lego. Okay, those Lego, if you have ever played the Lego, you know that these are the basic construction units. If you connect them differently with us, even if you are using the same units, you can get the different things like a castle, coffee cups, or trucks. Okay, so that can sort of like reflect what we are going to do in chemistry. We are going to put the atoms together in different ways to synthesize different molecules and investigate their properties and apply those molecules into our daily life. Some of them are very useful. All right, the second topic is about the classification of matter. Okay, in order to understand the whole world, we have to classify the matters into different category. Okay, before we talk about how we classify matters, let's talk about the states of matter. Okay, well, by the way, how do we define matter? Matter is something that can occupy spaces and has mass. Okay, so that's how we define matter. Anyway, for the states of matter, there are three basic states: solid state, liquid state, and the gaseous state. For solid state, you can see that these atoms are highly, or molecules. Okay, we're talking about the matter in general. But anyway, so those molecules, the units are highly organized in a certain pattern. Okay, because the distance among these units is so small, you cannot compress it too much. Okay, for liquid, you can see that the distance among the units is a little bit longer than that in solid state. Okay, so if you are talking about the which one is more compressible, then liquid is more compressible than solid. Okay, for gas, well, you can see that for gaseous state, the distance among the units is quite high. So that means you can compress the gas very well. Okay, so I think this picture reflects the basic difference for the three states. In Chem 2, you will see how we investigate the intermolecular forces for those units in the different states. Okay. All right. Now, classification of matter. Well, this picture is from your textbook. Well, on top of this flow chart, it's matter. Okay. Now, let's follow this side first. On this side, it shows you that matter, one type of matter is pure substance. Pure substance, okay, that means you can have only one component. All right, for pure substance, you can classify that to two categories. The first one is element, the other one is compound. Okay, well, how do we define elements? Element means a substance that cannot be chemically broken down into simpler substances. For instance, helium. Okay, well, we know helium is a single atomic molecule, and it has two protons inside the nucleus and two electrons outside. Okay, you cannot use chemical method to break the helium atom into smaller particles. There's no way for chemists to do it. But for physicists, they may have a way to do it, okay, but not for chemists. Okay, so in chemistry, this is how we define element. Another category of the pure substance is compound. That means a substance composed of two or more elements. Okay, for instance, water. Okay, we know that water formula is H2O. Okay, as you see that for element, it has only one element, of course, but for water, okay, it has two elements: hydrogen and oxygen. Okay, so this is how we define compound. If you have more than one element in this pure substance, that is defined as compound. Okay, we'll see a lot of examples of compound in our following weeks. Okay, now on the other side of this flow chart, okay, it's called a mixture. Mixture is the second type of matter, and for mixture, that means it's something that is composed of two or more components, right? Pure substance, one component, but for mixture, two or more components. And there are two categories in mixture. One is a heterogeneous mixture, the other one is a homogeneous mixture. Heterogeneous mixture, this picture shows us a very good example. That's sand water. Well, for sand water, you know the sand is not going to dissolve in water. If you have such a mixture, you see sand at the bottom of the cup and the water on the top. All right, so you can see the difference of the two faces with your eyes. They are not miscible to each other. Okay, so that is a heterogeneous. But for homogeneous mixture, like a cup of tea, all right, the very important property of homogeneous mixture is, okay, the whole body of this mixture is uniform. Okay, you cannot tell this part of this mixture is different from another part of the mixture. Okay, they look the same. Okay? So this is difference between these two types of mixtures. A quick practice here. Okay, I classify each substance as a pure substance or a mixture. Okay, first one, the wine. Okay, for wine, it's actually a mixture. Okay, because it has at least two components: alcohol, the ethanol, okay, and water. So, and probably if you are talking about some, better wine, you probably have some other trace amount of chemical inside so you have different smell, those kind of things. But the basic components would be alcohol and the water. So this is gonna be a mixture. And we know that I don't know whether you drink wine or not, but you're probably not age. But anyway, so when you have a cup of a bottle of wine, you can see that it's uniform, and so it's a homogeneous mixture. Okay. Of course, this question is just asking you whether this is a pure substance or mixture. So if you answer wine is a mixture, it's good enough for this particular question. Beef stew. Well, apparently it's going to be a mixture because you have beef and you have some other, vegetables, and you have water there, or different seasons, those kind of things. Okay, so mixture. Iron. Well, if you are talking about iron itself, then that's going to be a pure substance because you have only one component. And if you want to be more specific, iron has only one element, so it's an element. All right? Okay, pure substance for iron. Carbon monoxide. Well, if you are talking about a carbon monoxide itself, then it's going to be a pure substance. All right? And it's also a compound because you have two elements, carbon and oxygen, as we saw from the previous slide. All right, so this is this video. Let me know if you have any questions.